Okay, here we are. Doing stuff. Yes. Okay. Yes. Alright, let me pull this up. Okay. So we were here, and now we're here. Yeah, I guess we did G. Sure. Hello. Huh. Starting station. Great. Okay, so we got some modular arithmetic stuff going on. G from div 3. Maybe we could just do the div 3 today. We can start with that. Make it a bit interesting. Actually, sure, I'll do that. I'll do the div 3. Well, why not? This problem doesn't look that fun anyway, so we'll start with that, sure. Yeah, I'll do the div 3, fine. Is long. To check that every time because I change it so often. Alright. Hello. Okay. Alright, sure. We'll do it. On Sundays I do literally nothing. I do not think. I do not let myself solve problems. It's a forced thing to not tire myself out that much, I suppose. Although usually during school I end up doing homework on those days, which is fine because homework's not that taxing. Wait, why have I opened A already? Okay, whatever. Square of positive. Given the coordinates of his okay. What are we doing? Oh, wait. I'm confused. I don't need to do all four, but whatever. Sure. This makes sense, right? LX, RX, yeah. We don't need to do both. Doesn't really matter. The fact that it's a square. So just have n boxes in which cats may or may not sit. Okay. What? You? Okay. 203214. Yeah. Stepan's a very busy person. Today he needs to send in messages. Sending a message at moments 3 without turning it off. Okay. What? You sorted, eh? Yeah. Okay, x is 0. X is 0, x is -7. Is this correct? V of v, v dot pushback 0. For I is 0 up to n. Well, like... Okay, so if we turn it off here... Oh no. So the treatment of time in this problem is kind of unfortunate. Yeah, sure, okay. This seems fine, I think. I'm not sure. Thank you. Alright, is the rate AI of n integers? M integers bi. 16, 0, 12, 11, 10, 23, 15, 25, 7. Yeah. And M, VIN, BM, PFM, SFM, SFI is R. Yeah. Sure. All right. You gonna do this? I guess you're gonna do this. Eat the chip. Alice and Bob are playing a game on a checkerboard. It's H rows and W columns. Bro, what in the world is this? So, I mean, I have to catch you on the edge. Why are you not judging? Okay, whatever. Okay, so what's X? Are you serious? Okay, so if YA so if YA is less than YB, XB minus XA. If wait, so D mod 2 is 0. The Bob will win. So Alice will move to the left. YA is max. otherwise Alice will win. So Bob will move right. YB is min W. So this should work, right? If YA is to the right of YB, then if Alice will win, then Bob will move right. Sure, we don't need this. Also, draw Bob, draw Alice, draw Alice, Bob. Yeah, sure. You're still not judging. Okay, LHW, yeah, read in all of them. So if D is less than 0, print draw automatically, otherwise. If YA is less than YB, if D mod 2 is 0, D mod 2 is 1, then Alice gets the extra move, but yeah, if D mod 2 is 1, then Alice gets the extra move, but then she also, yeah, okay, so this is fine. D mod 2 is 0, YA is max 100, YA, yeah. YA plus, Y minus, Y plus, okay. D mod 2 is 1, Alice gets the extra move. If Alice gets the extra move, then she's going to win. So that's fine. Sure. I'm giving her a of n numbered. Also, Q queries of the form SDK. For each query Q, find the sum of elements AS. Huh? Okay. Okay. Well, that's weird. Why do you make us do that? You're still not gonna judge? Sure, thanks, Mike. Okay. Why do you make us do that? Why are you making us do this problem? I mean, sure, I guess, but... Okay, so... How big are you? 300. 330 million 30 million. What in the world? $30 million. Yeah, that's fine. Okay. So A S plus D times K minus D times T. If S minus D is greater than or equal to 0, S minus equals PV D. What am I doing? PV. F is equal to no wait, it's just F is equal to what are you? So you're S over N, right? What are you? Wait. So you're S over D. So if you're in this range, then we need to subtract 0. If we're in this range, then we need to subtract 1. Okay, yes. Sure. What are we doing? 3, 3, 1, 1, 2. So then 1, 2, 2. So your 2 SV is 6. SS is 4? What? Oh, I'm an idiot. R if j is greater than or equal to I, R minus U PV I j minus I. Okay. Let's get rid of this. Make sure this checks out. 513. Yeah, okay. Sure. Tuned into Q, VLAN. J0 up to N, J over I plus 1. F times AJ. Yeah. Minus 0 up to K. F is S over D. So you're at 1. Then we added 2. So we need to subtract out this. Okay. And then we're going to test the other one. Make sure you work. Make sure this works. Okay. Wrong answer on test 2. Interesting. Okay. Why? HW, XA, XB, YA, YB. Seen to HW, XA, YA, XB, YB. YA is max 100 YA. Player immediately wins as they place their chip in a cell. What? D mod 2 is 0. So if Y... Oh, damn, idiot. Yeah, that would actually be problematic. Right? HWX, yeah. Because otherwise Alice would actually screw up her advantage here. Yeah. Okay. Alright, sure. Mischievous shooter. You're gonna be in Q again? Once the mischievous and wayward shooter named Shell found himself on a rectangular field of size m by m, divided into unit squares. What? 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 Shotgun hits all targets in the chosen direction. The Manhattan distance to which does not exceed a fixed constant K. Why why would you make us do this? Oh my god. Are you serious, dude? You're not gonna judge? Bro, why did you not judge? I'll see if YA is greater than YB. Okay, so alright, so we're gonna God, okay. 4 it 0 it less than 4 it plus plus. So we're gonna flip you. Then we're gonna flip you. So we're gonna flip you, then we're gonna flip you, then we're gonna flip you. Okay, so you're gonna judge my, thank you. Swap Gij Gi. Sure. So we swap you, then we flip you, then we flip you, then we flip you. Yes, okay. Now, all we need to do is solve for one direction. So, what we need to do then is do prefix sums. So, vector VL PS and VL M. S G I J. plus equals psij. If R is C is J minus K. If C is R minus equals ab C. Can you please compile the correct code? Thank you. Okay, so something's wrong here, clearly. Seem to end up okay. Oh, wait, what? Wait. Do I have to plus K? Wait, but something's wrong here, clearly. Wait, what are we doing? I mean, we should plus K, but something's wrong here anyway. I is 0. I is 2. J is 1. 0, 1, 1. 1, 2, 3. So I is 2, J is 1. I is 1, J is 1, cur is 2. So we add 1 here. We do LO, R is I minus 1. C is J minus K. Should it be minus K? No, it should be minus K minus 1. Okay, thank you. Yeah, sure. Okay. Now we do plus K. We get the correct answer. Yeah, all right. So C into NMK, vector string GN for string SG, C into S, plus K. IT is 0 up to 4. Make the prefix sums. Cur plus equals PSI J. J minus K is greater than or equal to 0. Cur minus equals PSI J minus K. Well, R is I minus 1. C is J minus K minus 1. C is less than 0. R minus equals ab C. C is 0. Now, R is greater than or equal to 0, and C is less than or equal to J. Cur minus equals that. Yeah. Okay. Cool. That wasn't the worst, I guess. Alright, I guess while we wait, we can look at our code again. C into NMK, vector string GN, for string SG C into S, plus plus K, yes. I'll answer 0. Okay, cool. All right, nice. Okay, that's not bad, I guess. Well, our rank is going to drop for sure, like so much after these people start solving G, right? But we can enjoy our second for the moment. So the sad thing is, like, all right, we lost around 11 minutes of penalty to the Q thing. If my E had judged instantly, then we would have known. We would have known that. We would have known that we would have known that. So that's a shame. But other than that, that was pretty flawless, I suppose. So let's find my actual rank. 4th, nice. And we would have been 2nd if not for that. That's really annoying. That's really annoying. But whatever. Sure, I'll take it. Okay. All right. Can you explain G? Yeah, sure. If anyone wants me to talk about any problems, we might as well do a post-contest discussion right now. Because why not, right? Okay. So G. How fast was it? It was like, oh, it was pretty fast. So G, I mean, the statement is so, right? So like the general, by the way, I don't have a drawing tablet. This is going to be painful. The general gist that we want to do is, without loss of generality, let's only do the up left case, right? So what we want to do is we want to have this triangle that we have, and then we want to move down a row. So we want to move down a row. I can't draw. Okay, so the stuff we're going to gain is this. So we're going to gain this entire row of values, which is easy to do with prefix sums. And then we're going to lose this diagonal of values. And the key observation that made my code so simple is that this diagonal is of size less than or equal to square root of nm. Now, specifically, it's the minimum of n and m. Sorry, I don't have a mouse. I'm drawing with trackpad right now. So this is size min and m because, you know, obviously, like it's a diagonal. You're going up and you're going right. So either you're going to hit the top or you're going to hit the right. So you can do diagonal prefix sums to exclude this, or you can literally just iterate through the diagonal and subtract out each value manually. And that will work because min n m is square root 10 to the 5th. Yeah, drawing skill of a newbie. Absolutely. Sorry. Sorry about that. Okay. Right. So yeah, so like so we can literally just exclude this diagonal manually. I mean, you can also do diagonal prefix sums and it'll be kind of painful, but yeah. So then, of course, there are the other cases, you know, this, and this. But the trick I used in my code is we can just flip the grid vertically and then run this case again. And then flip the grid horizontally and then run this case again. Run this case again. Because, you know, it'll just work. And then flip the grid vertically once again, and then run this case again, and that'll handle this one. So you don't have to write 4 equivalent pieces of code. You only have to do 1, because you can flip the grid as you please. So, like, that's what's happening here. That's what this is. This is flipping the grid horizontally, I believe, and this is flipping the grid vertically. And then you just do some math to find out the diagonal, and then you literally just traverse the diagonal and subtract stuff out. That is how that works. Yeah, it is. This is probably like the cleanest way you can. This is probably like this is very, very clean, I will say. Like you probably there might be a couple other tricks you can use, but this is like a very nice way to handle this problem. The hardest part is the prefix sums, which are very easy because it's just on rows. So it makes life good. Man, we really, god damn, dude. Why did I lose I lost 2 ranks to Q issues. It's actually so annoying. Golovana, by the way, good job, but we lost 2 ranks to Q issues. I'm mad about that. Were there Q issues in the contest, or was I just like alone here? Yeah, we only moved down. So like we iterate over every column. We iterate over every column, like from left to right or something, and then we just move down that column, and we keep track of the sum, and we're keeping track of the sum given that this is the bottom right corner. Okay. I'll go backwards. F is very standard, which is like a shame, but it's a div3, so whatever. Like I've seen a problem like this before, right? So fact, if k is big enough, so like fact, you're going to make at most n over, what is it, d jumps. So if d is greater than or equal to root n, then you can just do it. You can literally just simulate the process. You can go through all the indices and add the sum because it's small. It's n root n, right? Q root n, so that's fine. And the other case is if d is small, but if d is less than or equal to root n, then there are only at most root n possible values of d. So we can compute prefix sums for every possible small value of d, and then do some math to figure out what the answer to the query is. That's pretty much what this is. So like we fix this value b, I say 250 for memory's sake, doesn't really matter, because you have a lot of memory in this problem. And then you do prefix sums. You have to store how does this work? So you have like, the way to do these prefix sums is like, let me type this out. So the way to do these prefix sums is like you have this sum, like the query is the sum of, what is it, ai plus as plus d times I plus 1, right? So what we need are actually 2 prefix sums. We need the sum of ai times floor I over d and like you can kind of see how like this separates into like d separate problems where like you have all the numbers that are 0 mod d, you have all the numbers that are 1 mod d, etc. And you can do prefix sums on like each of those lists independently. So you do that, and then you just have the sum of ai for the same parameters. And then given these 2 sums, you can like this might give you like, for example, like a what is it, like 14 times 7 plus a 16 times 8 plus a 18 times 9, right? But you really want a 14 times 1 plus a 16 times 2 plus that, right? So what you need to do then is you need to subtract out 6 times a 14 plus a 16 plus a 18 plus dots, and that gives you exactly the sum you want. So that's why you have 2 prefix sums. You have one prefix sum that handles this like weird increasing index thing, and then you have the other prefix sum that's like a normal prefix sum. And then you use them both to get your answer. Yeah, I'm sure it's similar. Which trick? The F? I mean, it's just square root decomposition. Like that's pretty much all it is. I need to charge apparently. This is just an instance of square root decomp. Where are we? E? Okay, E is fun. So think about this problem. So there is a predetermined winner, right? The predetermined winner is like, so Alice is going to move down one, Bob is going to move up one, and then Alice is going to move down one. And then the person whose turn it is when they end up on the same row is going to be the person who might win the game or not. Yeah, I did G. You can rewind. The person whose turn it is when they end up on the same row is going to be the winner. So like we have Alice, Bob, and then Alice. And then because it's Alice's turn when they end up on the same row, that means if they do collide, Alice is going to be the winner since she's the one that like made that move. And similarly, if there are like two, then Bob is going to be the winner if they end up on the same row. So this depends solely on whether the distance between them is even or odd. If the distance between them is even, then Bob wins. Otherwise, Alice wins. And so, yeah. So what we need to do then is determine. So like, suppose without loss of generality, Alice is going to win. Alice is the one who parity favors. Then we need to see if Alice can catch Bob, pretty much. So if they're already on the same column, which is actually the case I missed, if they're already on the same column, you need to modify this else. If they're already on the same column, like the winning player is going to win regardless. And if suppose Alice is winning and suppose Bob is to the right of Alice, then if Bob moves to the left, then that gives Alice an advantage. Alice can catch up easier. So Bob will want to move to the right. And so he's going to move to the right as much as possible and either successfully escape or be caught by the end of the grid. But the general idea is if Bob is to the right, then Alice and Bob are going to move to the right as much as possible. And either Alice will catch up or they'll be caught by the end of the grid. So you pretty much all you have to do is simulate. Like you just have to. So if Alice is going to win, let's say, and Alice is to the left of Bob, then Bob is going to move right as much as possible. So you just have him move right for all of his moves, and Alice is going to move right as possible as well. And you just see if they end up on the same column or not. And you note that Alice may have an extra move if she's the winner. So that's why like you have ceiling d over 2 and floor d over 2. And then there are 4 cases pretty much, and they all end up being pretty similar. Either they all move left or they all move right, depending on who's the winner and whether they're left or right to each other. And then there's this special thing where if Alice is below Bob, then obviously there's nothing you can do. That they're never going to collide. So then if the coordinates end up not being equal, then the loser successfully evaded the winner, so it's a draw. Otherwise, you just find out who won, and then, yeah. BFS probably wouldn't work, because the sum of h does not exceed 10 to the 6th. Why'd they do that? Why? Okay. Okay, I guess that makes it a bit easier. I guess you could maybe simulate it directly, I guess. But I don't. Okay, I guess it's a div 3. They can be nice like that. Sure. I didn't realize that actually, but whatever. Yeah, W is up to 10 to the 9th, but if H, like the moves are going to be bounded by sum of H, so you can in theory like simulate it. Because I mean every move the difference in H goes down by 1. Yeah, you could do that, I guess, but it doesn't really change anything. I mean, you just have to. Actually, if I had done that, I probably wouldn't have made this bug, because the only bug I made was that if they're already on the same column, then I'm going to have Alice move left too much. I'm going to blow Alice's advantage if they're on the same column, by having her move left 1 over, which is bad. So like that's a dumb bug to make. That cost me 2 ranks because of queue issues, which is very annoying, but whatever, what can you do? It's a div 3, doesn't really matter. And okay, we can talk about the other problems too. This one, I don't know, like, suppose n equals m. Suppose n equals m. I'm just gonna type this out because I don't have my, I have my drawing tablet, but I don't have the cord. Like, I don't have the thing that lets you plug it into the laptop. Oh wait, no, I do. Wait, do I? Okay, yeah. No, wait, I guess I do. Okay. That was previously the issue. I guess we found it, but I used to not have the cord, which means I just couldn't plug it into the laptop, which is annoying. But now I have both, but I'm still gonna be lazy because whatever. It's not a, we're not doing a formal discussion anyway. So yeah, I mean this one, like, if n equals m, then sort A, sort, and then sort and reverse B. And that's optimal because exchange arguments, pretty much. Like, find if you swap two elements, then you can't make the answer better from this. So this is optimal. And then, so what this means is you're gonna have like some prefix of A small, A big. No, wait, B big. You're gonna have some like prefixes of this. And like, suppose these are aligned, right? Then basically you're gonna have every element of this prefix of B bigger than A, and you're going to have every element of this suffix of B smaller than A. So you want these to be as small as possible, and you want these to be as big as possible. And yeah, so like basically that means the absolute value for here is going to be BI minus AI because B is bigger, and the absolute value for here is going to be AI minus BI because A is bigger. And from that, you can guess or hope or have faith that in the sorted reversed list of B, you're always going to take, or in the sorted list of B, you're always going to take some prefix and some suffix, and you're going to leave out some elements in the middle. So like, you're going to take some stuff. You're going to take some stuff. What? Yeah, you're going to take some stuff from the beginning of B. You're going to take some stuff from the end of B, and then you're going to not take some stuff in the middle. This is this is a very formal proof of this fact, but it all comes from this idea that if you want to reverse some part of B, you want to reverse B and then match it like that. Because I mean, you want to make this part as big as possible. You want to match the biggest values in B with the smallest in A to make their difference as large as possible. And then once it reverses, then you want to match the smallest values in B with the biggest values of A, so that it works. So you can probably, there's probably an equivalent greedy solution where you take the element from the end of B that gives you the higher reward. And that probably works, I would imagine. But whatever. It might actually not because of convexity issues, but I'm not sure. It doesn't really matter. Just iterate over the suffix and prefix you take of B and then win. Like, just see how many elements you take from the beginning of B and then do it. Pick the pair that gives. Yeah, I think that works. I think the greedy variant would work. Yeah, I'm pretty sure the greedy variant would work. You can do it with like greedy stays ahead or some variant of that argument. I think that works. The proof is not completely clear. but I think that's correct. It's not completely clear in my head, but I think it's correct. It makes sense that it would be correct. People want me to do the first three. This one pretty much like each segment of time is independent. Like the segment of time between 4 and 6 is independent of the segment of time between 6 and 10. Because like you have to turn it on every time to send your message. So like between 10 and 13, either you turn it off and pay B to cross the segment of time, or you pay A times 13 minus 10 to cross the segment of time. And so like for each segment, you just decide whether you want to leave it on or turn it off. And then you implementation trick to put a 0 at the beginning to handle like the fact that it has to be on at the beginning and you have to cross this initial segment of time. Makes life a little bit nicer. Am I going to participate again? Probably not. Not for a while. I'm not doing that div one. I'll probably virtual it like sometime soon, but I'm not participating in it. I'm not gonna participate until I feel like I can get LGM, because I don't know. I don't really like doing contests, so I'd rather not. I prefer to do virtuals because they're just more convenient. This one you just do it. So for any position where they're already equal, you can just ignore it. For any position where they're already equal, you can just ignore it. So then you have some positions that must go from 0 to 1, and some positions that must go from 1 to 0. Right. So suppose they're A that must go from 0 to 1 and B that must go from 1 to 0. Then you can repeatedly decrease both A and B by 1 by taking a 1 and move it into the 0. You can take one of these 1s and move it into a 0. And then you can also just decrease A by adding a cat directly, or you can decrease B by removing a cat directly. So given that you can do these three things, the cost ends up being max of A and B. Because you can either decrease both by 1, and then once one of them runs out, then you have to decrease the other one individually. So that gives you that. That is B. What is A? I remember A was... Oh yeah, literally you just find the min x coordinate and the max x coordinate and square it. That's it. Just find the minimum of these x's and find the maximum of these x's and then square them. Yeah, div 3a, it's fine. Okay, cool. Anything else for this contest? Otherwise, we're gonna move into our normal practice and everyone can drop off. Yes. I think, yeah. That was interesting. Really sad the Q issues screwed me over, but what can you do? Better thing to do would be to not make a mistake on E. If we just not done that, then everything would be fine, but whatever. It is a shame. Not many souls on G. I guess like people did not want to do it, which makes a lot of sense. Or they just damn Django started late. Okay, that makes sense. Yeah, he could have. Probably wouldn't have beaten Golovanov, but he could have gotten second. Yeah, okay. Alright. Back to quote-unquote real problems, I suppose. Well, 3,000 problems, which are more real for me than anything else. So this one looks like it sucks, which is like really a shame. 10 to the 12th. So we have some like back and forth stuff here. Most of the reason why I'm not doing contests is because waking up is hard. Contests are 9:30, which is like which is not early by any means, but my sleep is like very off whack right now. So 9:30 is very early for me, unfortunately. Which I don't want to deal with. Series of numbers from N, yeah, so blue is counterclockwise. Project apps? No, not really. I'm not doing classes like that. My classes are like more theoretical CS stuff. It's like M can be anything. M can literally be anything. M can be one. I mean, something to do is simulate n steps. So then we're gonna stay in red. We're gonna stay in red until we get something that launches us into blue. Then when we get launched into blue, we're gonna go one back. So 2 moves is gonna take us 1. Then what? So if n and m are close, so if m is close to n over 2, then simulation would work. Simulation would work. I mean, it could be a huge jump. How would this work? Yeah, good luck with that. That is the move. Grind for yourself. Yeah, I mean, if your skill is a if your performance is a random variable, it's gonna have ups and downs. Well, it's fine to be. Variance is expected, but so it's good to look at what happened and fix it. So, what's happening here? We got stuff. If we could simulate both, we'd win. That's the thing. If we could simulate both, we'd win. Simulating the bouncing between red and blue is easy. Simulating the staying in red and then waiting for a blue is harder. How do we compute how long we stay in red? Probably the trickiest part is like m equals 1. And we have all these blues, and we just hit red like every once in a while. Imagine if we had queries. That would be evil. for the first time this whole like winter it finally snowed once, which is fun, I guess. It's a nice change of scenery, but never enough to. Well, I probably wouldn't screw it with it in college, but I haven't had a snow day in a long time. It's sad. Okay, so yeah, I guess been everywhere. It's a little bit. It's not that much, but it's nice. Starting station and the initial value of t. It's like the input's almost random. It's almost random. And like if we do double steps, sometimes we're gonna jump twice, sometimes we're gonna cancel out. How do we deal with almost random input? If M was big, this would have been fine. Can we repeat quickly? I mean, probably not, right? Probably not. Why do you have so much memory? Do all these have so much memory? No, this is a lot of memory. Why does this have so much memory? Okay, so the only hard part is if m is small. That's the only hard part. Because otherwise we can do some stuff. Like this is n over m squared something? It's like n squared over m. That's the problem. Is this like a continuous story? Nice. Yeah, nice. Okay, cute. 10, 4, 3, 1. Okay, so if m is less than root n, what do we do? How do we handle this? How do we handle this? Why did they choose the input specifically for this? That's interesting. So, I mean, bounce state is like what? If we could simulate the second part quickly, then we'd be fine. How do we simulate the second part quickly? We have 10 to the... What? No. How does this work, man? How does this work? And we know it's not going to happen that often. We know that if m is small, we're not going to hit blue that often. We're not going to hit red that often, whatever. We're not going to hit the small one that often. Can we use that somehow? I mean, so we can just binary search. We just need to know whether we're going to hit or not. can do this in root n. Wait. We can do this in root n. Okay, so that loss of generality, suppose red is big. Okay. N root n log n. That's where we're at, right? N root n log n, but it's 10 to the 5th, and it's binary searches. So like, it's sorting in binary search, so it's not that bad. It's yeah, this is fine. This is fine. Okay, this is fine. We'll do this. I'll be right back. Okay, so what we need to do then is this, right? So okay. So C end and M. Okay, so done multi-tests. Mic is on. Yes. What? How did I screw this up? What do you mean? Oh. If R is less than M, true. Yeah, okay. Sure. Alright, now then, what we need to do is do some stuff. So bool rev is equal to 0. If m is less, so if m is small, rev is equal to 1, p is equal to n minus 1 minus p, m is equal to n minus m. No, let's do this. Let's p is equal to x. Okay. Allow ants is smart x if local. Allow jor is sim x. Pr ants jor. Cert ants is jor. Okay, so vector okay, so so we need to do this advancement. So we have x plus t minus 1, x plus, yeah. So x plus 0, x plus t, x plus 2t minus 1, x plus 3t minus 6, etc. T minus 3. Yeah. Yes. Okay, so const LB is 300. VL tote. P norm P plus step Ti. T S is step T I times B. Wait, how does this work? Wait, does this work? Wait. Does this even work? This might not even work. Cause suddenly this might not even work. Cause suddenly, like, we need to So, like we're moving 900, 899, right? Then suddenly we're going down to moving 600. So like these are going to be differently spaced. Huh. These are going to be differently spaced. What does that mean? Does that mean we're screwed? It might mean we're screwed, yeah. Yeah, this means we're screwed. Damn. Okay. So we need a new thing. That's a shame. Yeah, inspiring, I guess, sure. We call it that. Okay, I mean, we're basically, nah, this isn't gonna work. This is gonna be n squared. The probability that we randomly visit one of you is not going to work. We need to do these steps efficiently somehow. How does this work? So then we have this. Then you're 600. Then you're 599. Then you're 598. Etc. Etc. Then this doesn't work. We define in sublinear time. Any sublinear, root n log n is fine. Root n log n is fine. We just need to do it. How do we do this in even root n log n time? Second line, 200 years S&T. Right, so like, See, this is a good example of the statement being natural. Like this statement makes perfect sense. Like the formulation as the metro is like, it makes perfect sense. It doesn't infringe on the mathematical structure of it. It doesn't like overcomplicate things. It's a good statement, but like cramming a story where it's not needed is a shame. But this is good. I mean, you could easily formalize this. Like you could easily just like give this process and then tell you to simulate it, but this is fine. In root n login, right? In root n login. Wait. Wait. Birthday paradox. Hang on. Birthday paradox. Wait. P is equal to m minus 1. If ax is not equal to negative 1. T mod equals Wait, this actually works. Wait, this actually works. Hang on. Wait, this actually works, wouldn't it? What? Yeah. This would work, wouldn't it? Wait up. N is equal to 3 plus RNG mod. Okay, sure. Now wait. Doesn't this work? Doesn't this work? Really? Huh? Real A and -1. If AX is not equal to -1. Wait, how does this work? Hmm? Um. What? Huh. Okay, let's try this. You really never hit? Oh, wait. Well, I guess, I guess this is fine. Wait, why? What? What? Oh. I didn't. Okay, I'm an idiot. I guess this is fine. Okay. That's really dumb. Are you serious? Oh, you don't work. Okay. Oh, that's why. Are you serious? Bro. Come on. Come on, man. Please tell me this doesn't work. Like, let this get TLE. Come on, let this get TLE. What? Oh. Yeah, sure. Let this get TLE, man. Bro, come on. Okay, thank you. Thank you. So what's the biggest cycle then? X equals RNG mod n. Yeah, sure. So what is the worst case then? Do you have a worst case? Why do you make it past 28 tests, by the way? Can you tell me that? Tell me why you make it past 28 tests. This is T mod n. What's like... We need prime. Sure. We can do this. Serious? How big do you get then? Why do you have so much? Why do you have such a memory limit? You make life easier somehow. Wait, why are we on 17? Keep running you. Well, X is T mod n. Pair TTV is PX. So where's a big one? Six oh six. 99394. I mean, you're not much worse. It's like, what is this magic case? Nine eight eight nine four. What? What is this magic case then? Oh wait, I'm sorry, why? Okay, I see. Let's do this. P is less than M, P is norm P plus T. Otherwise, R is norm P minus T. Min okay, so we just need to do this smart simulation. So R is norm P minus T. So you'll either be M minus R, so you'll either be M minus 1 minus R, or M minus 1 minus R. So you're going to go down. You're going to go down this. Let's do this. D is min m minus 1 minus r. P minus m. T minus equals 2 times d. P minus equals d. While P is greater than or equal to m, why? What? Where the hell are you getting stuck? Oh. P. Oh, wait. That's why. Why exactly? I mean, you're what? I don't understand. Am I not subtracting t? Am I not subtracting t? Am I not? Am I not? What is going on? Okay, sure. All right, we'll do this. This is really stupid. Wrong answer on test 11. What? P is greater than or equal to M. Well, R is norm P minus T. Max 0 LO, min. T over 2. M minus 1 minus R. P minus M. Oh, wait, that's why. Because these are hard tests. So there are tests where np.size is greater than 1e11. Time limit exceeded on test 11. Let's do this. What are these tests? I'm so confused. What are these tests? Wait, what is this? Wait, how did I get 1e6 there? Can we make it bigger? mean, if we could just... Let's try this. Status integer divided by 0. Huh? T mod equals, oh, that's why. Let's try this. I feel like combining these two might have some merit, but I'm not sure. Nice. Okay, cool. Awesome. Okay. I guess that's fine. That's pretty dumb, but okay. Yeah, all right. We're gonna move on. That's stupid. How's this 2900? I guess it's got a bunch of sols from like, yeah, lower people. Interesting. Oh, Tealy, oh, damn. Oh, that's a shame. Time limit exceeded on test 14. Well, that's a shame. Nice. All right, be that way. Yeah, it's kind of dumb. This is pretty dumb. It was a pretty dumb solution. I mean, it makes sense that this should work. It makes sense that this should work. Wait, these are 100,000s? Huh. These are all just 100,000. 100,000 with small m. And somehow that breaks it. TC plus 1. Oh, damn. Okay. Oh, wait, no. It's because, yeah. So this makes you explode. You reach like 1 million. Huh. Interesting. Why does this make you explode? Square root t-comp, I don't know. You're not going to see it other than div3s and edges, mostly, because well, actually, I don't know. Div2s could, it could happen. Like, yeah, it can't hurt. It's not like that hard of a topic. It won't take that long. Like, it's just if x is small, do something, otherwise do something else. You're just combining two different algorithms and taking the minimum of them. Okay, well, this was stupid. And that was an FST, which is a shame, but whatever. Whatever. All right, well, look at this. God damn it. Stop. Ah. Jesus. Okay. All right. Focus. Okay. I need to. This is absurd. Bro, like, chill. You gotta stop lagging on me, dude. Okay. You gonna work? You not gonna work? You really not going to work? Thank you. Okay. So we're not touching E. That's for sure. Due to technical reasons, the round will be unrated. Okay, maybe we don't do this one then. What is with Technocup? Why is Technocup always so cursed? I don't really want to do a 2800. Don't really want to do a 3500 either. Let's just not do this one. Why have I done this? Why are you 2700? Okay. I guess we're doing E. Why is F 2700? Okay, cool. You're given an m by m grid. Each grid cell is filled with a unique integer from 1 to nm, so that each integer appears exactly once. You can choose an arbitrary cycle of the grid. Find any sequence of operations. So sort the grid so that the array cool. Cool, man, cool. Okay. Cool, bro. Cool story. Ah, God. I mean, it's kind of like that grid puzzle where you like shift the tiles around. And that pretty much is what it is, but Bro, why you gotta do this? Okay, so N and M are at least 3. This is what old constructive used to be like. Be glad that Codeforces is so much nicer now. Because this is what problems used to be like. This is what we had to deal with. This is what constructive used to mean. Now it's actually interesting. Okay, so it's different than grid puzzle because we can choose any permutation. We can choose any cycle. We don't have to use the 9. We don't have to use the biggest element. Why does that make life easier? Why does that make life easier? Why do you make life easier? What does this do for us? So let's consider the 1. And let's just move it into position. Now let's consider the 2. And let's move it into position. Can we sort 2 rows? Okay, wait. So we know that, okay. We are given that N and M is 3 is always possible. And thus, this is easy. Okay. I see your problem. I see what you're doing. We are given that N and M is 3 is always possible, which means that we can reduce it to 3 by 3 and then brute force 3 by 3. 9 factorial is small, and thus this is fine. Smart problem. Okay, I'll give it to you. I wasn't expecting reduction. Okay. I like this more now. Okay, so first thing we need to do. So what we do is we reduce so vector VLG so while n is greater than 3, so how do we do this? This is a little bit annoying. Okay, so vector VL targ and VL targ ij is equal to I times m plus j. If Gij Okay, so we're gonna prefer up and left. and that's fine. Okay. Oh, these are the elements. Okay. Vector. Void op vector pl seek vector vlg. Okay. Vector. Wait. This actually work? Nice. Okay, sure. I'll abuse references. Yeah. So vector vlng is clone g. So what we're gonna do we have to? No. Okay, so we're moving 1 to 2, which means ng, no, ns. nr nc is grc. Op the pushback grc. Yes. Vector vlng is clone g. Vl op for I is 0 up to seek.size. Yeah. G is ng. Find G targ. Maybe if we do this, right? Then we move you here. Move you here. Move you here. Even if you're in my way, right? Move you here. So void stop pushback. Yeah, okay. So void m left. If r is greater than 0. So if r is greater than 0, then SQF, so square forward is going to do this, 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 this. R minus 1, C minus 1. Else SQR, R, C minus 1. R is greater than 0, SQF, R minus 1, C minus 1. Else square reverse. Yeah. If R is greater than 0, then square R minus 1C. Square reverse, otherwise square forward. C is greater than 0, then square reverse. What are you? So you're R minus 1 square reverse, otherwise square forward. Square forward. R, yeah. Square forward, R minus 1, C. Assert R plus 1 is less than n. So C is greater than 0, then square forward. R, C. If C is greater than 0, square forward, same row, C minus 1. Else square reverse RC. Right. Yeah. Okay, cool. Okay. So auto RC is find G targ. So we're going to find the last element and move you all the way up. Targ n minus 1, 0. While r is greater than 0, m up. then okay, now we do a single square reverse n minus 2, 0. Okay, perfect. If run else Gij is ai times m plus j. Wait, what am I doing? Okay. While c is less than j, m right. I'm very confused. Okay. Perfect, 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 perfect. Okay, now we do the same thing, but analogous to columns. So, while c is greater than 3, for L of j is n minus 1, j is greater than 2, j minus minus. Pretty much do the same thing. Find g targ j m minus 1. Okay, so assert n equals 3 while m is greater than 3. G targ 2 n minus 1. R is less than 2, m down, RC. Okay, now do the same thing pretty much. So auto RC is find G targ 0 m minus 1. Move you to this. auto RC is find G targ 0 and -1, right? Find G targ 0 -1. Well, R is greater than 0, move you up. Well, C is greater than 0. Okay. Auto RC is find G targ 1 and -1 while R is greater than 0. So then we do a single square forward, 0, row 0, and -2, -1 is M. Okay. Beautiful. All right. Beautiful. Let's do it again, just to make sure. Let's run you 100 times, just to make sure the asserts don't fail. Assert valid RC. Beautiful. Okay, good. All right, now we just need to solve this part. So we convert it to a permutation and then do that, right? So it's a little bit annoying because we need to so okay, so we have a permutation. This might like take too long. So what we need to do is vector VL NG and VLM. There are not many possible cycles. So like stuff. There are not many possible cycles. It's a really, it's a really annoying problem. How's the grind going? It's like fine. We got fourth, technically second in the Div 3 today, and I had a couple rough days in the beginning of last week, but it's fine now. Rough as in like I couldn't solve anything, but now we're like back on track, I suppose. I think it's just variance, honestly, but whatever. Vector VLNG. So we know N and M are 3. So what we need to do then is convert you. So for Li0 is this an N I plus plus. For Lj0, J is an M J plus plus. NG IJ is GIJ over PM 3 times GIJ over PM plus GIJ mod PM. We need to, yeah, okay. How's this work? So 29. So we have 14 columns. So 29 and 16, which means you're 5. You're 7. You're 0. You're 1. You're 4. Yes. You're 6. Sure. And then you're 3. You're 8. You're 2. Beautiful. Okay. Now, what we need to do then is some scuffed stuff. How big is our time limit? 2 seconds. Okay, I mean, we'll speed this up if we need to. This is fine. We can, wait, what is 9 to the 9? Oh, yeah, this is fine. Okay, yeah. We can speed this up if we need to. For now, map vector VL vector PL TR Q vector VL Q Q dot push NG while not vector PL ops VOP VOP dot push back square F IJ0 square R IJ0. Okay, sure. Op X NG0. If not tr.count ng trng is equal to gx. q dot push ng. Yeah, you're gonna take a while. Oh, yes, yes, yes. Awesome. Okay. Okay. Beautiful. Okay. All right, that makes life so much easier, dude. Oh my God, you have no idea. Okay, so we do not have to worry about. So so n equals 3. So actually, okay, so this is always possible using only 4 cycles. Interesting. That's an interesting property. Can it be like, can bigger cycles be like reduced to 4 cycles somehow? Like maybe they can. Maybe somehow that works out. That's interesting though. Yeah, so we can always do this with 4 cycles. Which means that, yeah, which doesn't necessarily mean that 4 cycles span all cycles. It just means that it's always possible. Okay. Okay, so we need to save the map operation, right? Okay, so we could do smart hash or we could not. Let's try not. So map ll vector vl all. So vl a 9. VLG and VLM. Auto hash is equal to all hash g is equal to g. Okay, so map ll q dot push hash ng lr is q dot front is all g is all r q ll. If not, tr dot count h trh. Okay. Segfault. Why? Why? No, that's why. Damn. You need to be faster. You need to be faster. You need to be just a bit faster, right? You need to be just the slightest bit faster. Yeah. Int. Let's see how much faster this makes you, right? Okay. That's useless. Let's get rid of the vectors. Okay, let's do smart hash. If we could do smart hash, then everything becomes easier. Because, yeah. We can speed this up a lot. Template. Okay. Using map TG. Pair T. TG. How much faster are you? Better. Much better. We still need smart hash, don't we? What? I didn't, Better. Okay. Let's do some stupid things. Does this make life easier? God damn it. Okay. Okay. Fine. All right, look. So we need to do smart hash. Okay, so VL fact 1 1. Fact dot push back I times fact dot back. Reverse. Okay, I don't need to do this. Why? Oh. Do compile. Why are you not printing fact? Do I have? I didn't print fact. What am I doing? I could have sworn I typed that in my head. Okay, yeah. So sure. All right. So now, R is equal to 8. For LOYX, BL mark. For LJ0, J is less than Y, J plus plus, if not mark J, S plus equals fact R. Minus R. Yes. We need to do this. Then mark Y is 1. For auto XA, for LOYX, for LOJ0, this could be garbage. Why are you not in order? For auto XA, for LOYX, for LOJ is 0, J is less than Y, J plus plus. If not mark J, S plus equals fact R. PR YS. Okay. A. This is a mess. $750. R. Okay, so thank you. Oh, that's why. Can you, hello? Terminal? Okay. Okay, thank you. Do you work now? 768. Okay, there we go. Can you not be an idiot? Can you just stop that? Can you stop that? Thank you. Okay. Array VL all vector T all F. Vector. Okay. If not this H, segfault. Beautiful. Okay, now finally, while t is not equal to s, vector pl back, pair t rx, pair LL equals tr t. T is equal to v dot f back dot push back v dot s. Okay. Reverse back dot begin back dot end. For vector. What am I doing? Beautiful. Lovely. Okay. Now we just print the ops, right? Print the ops. Cout ops.size for VLV ops. Right. Cout v dot size. Cool. We do a lot of ops. Okay. All right. Well, here we are. It's a lot of code. That's a lot of code. That's a lot of code. Jesus. Okay. Local. All right. Let's run it on the samples, and then we go. So 7856. So 6578. Yeah. Four, 6, 5, 1. That works. Okay, cool. All right, let's do it. You have the same runtime per test case. It should be fine. Cool. 1325. All right, that's fun. That was a problem. That was annoying. That was tedious. God, man. Why do these... Oh my God. Yeah, it snowed more. Damn. It snowed a lot more. I guess it's been snowing the whole day. Cool. Okay. Alright, well that was fun. It was very cool problem. Very, very cool. Very, very awesome. Look at this. I don't know. I mean, it's an okay idea. Like you just you reduce it and then you and then you reduce it and then you write brute force and then it works. And there's a lot of brute force going on, but yeah. Well, okay, sure. Yeah, sure, man. Sure. Sure, dude. Brute force implementation tags on the 3100. Awesome. Why is this round so weak? Interesting. Like not many. Like usually second is 3500. That's interesting. Oh, it's because there was another right. There's another thing going on. People did this here, I suppose. Yeah, there's tourist. Okay, sure. So this is like another div 1 in itself. And this was 3200 here. No, it was 3100. Damn. Okay. So maybe this could have been harder if it was different. Well, whatever. Stupid problem. Not really that fun. Like, I guess coming up, realizing that you can do that idea is nice, and then nothing else about it is nice. So how big does this get? It doesn't, like, as long as you're under 25,000, then it's fine. Oh, they use 6s. Interesting. Yeah, I do not use 6s. $20. 5,000. That's fine. Okay, cool. Max tests. Yeah, 70. Okay, I guess this might be worst case. Close to worst case. Cool. All right, interesting. So only need around 30,000 operations, I guess. Sure thing, bro. Sure thing. Sure thing. It's good practice, I guess. It's not bad practice. It's implementation practice, which has merit. It's practice thinking about implementation, I guess. Which is cool. Find any sequence of operations to sort the grids. Yeah, okay. Well, I did the div 3, but I kind of want to do another virtual because I don't really count the div 3 as practice. It's more just showmanship. Div 2 virtuals are not the best, but they're the best alternative I've found so far. So I'll do another one of those. That was the hardest problem here, right? Like there's nothing else worth doing here. $67 solves. Damn. Well, I guess it's split between 2 rounds. Yeah, that's a fun problem. And nobody who looked at it wanted to do it, right? Like, why would you want to do this problem? Why would you voluntarily do this? Took BenQ an hour. Took Radewoosh an hour. Jesus. It took everyone who tried it like almost an hour just to code it because there's so much to do. My God. My God, man. What a problem. Yeah, and there's nothing else worth doing. Okay, sure. All right, we'll do a, I'm gonna pick a random name. Do a div 2. Did this one. Okay, sure. All right. Read test cases. All right. Be right back. Okay. Why do we have 2 base codes? Okay, we're gonna have to do this every time, aren't we? Cool. All right, here we go. Nice. Okay. Okay. Good timing. Yes. The Martian Gardener. A's, right? Okay. C and S. Oh wait. You want it to be like this, right? Why do you want it to be like that? Okay. Writing them without. Oh wait, shoot. We can't just do that. Wait. Wait, what am I doing? Okay, C into S. String A, B, C. For car DS. To do something like this, right? A, B, B, B. Break. Yeah. Sure, okay. So for I0 up to S dot, like SI is A is A. S is S dot substir OI. So 3 plus S dot substir I plus 1. Yeah. Okay, this is annoying. It's an annoying problem. Will you let me submit? Thank you. Gardener in the array. The gardener has an array of n integers C1 to n. Wrong answer on test 1. Wait, does it have to... Oh my god. Okay, wait. Bro, okay, look. Jesus Christ. Bro, this is so annoying. I'm seeing this now. So if we have A, B, right? How does this work? Oh my god. Jesus. Okay, so this is sad. If S0, oh my god. If S0 is A, so if we have a B in the front, right? So if we have an A in the back, holy Christ. If we have an A in the back, make you bad. We have an A in the back. S dot back is A. If S dot back is A, print S0, S dot substir 1 and minus 2, S dot back. Else if S0, so otherwise S dot back is B. So if S0 is B, so otherwise S dot back is B. So if S0 is B, if S0 is B, right, then we have a B in the back. Yeah. Okay. Else. Otherwise what? So we have A and then B. So if we have okay, so if we have any B in the middle, right? Then print U for eyes 1 eyes less than s dot size. God, man. Why? 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 What do you mean? What do you mean? Oh. Okay, so if you're A, then this is fine. Why does this work? If S dot back is A, if S dot back is A, oh my god, dude. If S dot back is A, S dot front is B, this might not work. So if you're equal, okay, so how about S0 else, so if we have B, A, right? So this works for AB. What about BA? So if we have A and then B, right? If we have any B, do this. Otherwise, if we have B and then A, otherwise, if we have B and then A, otherwise we have all A's. Let's do it in reverse, right? Let's make C longer. So we have B and then A, right? So for the first B, so if we have B and then A, right? So if we have a B, let's make you the string of A's. Otherwise, if SI is B, so we have B, A, B, A, right? Yeah. Jesus Christ, man. Oh, wait. Okay, so if we have B and then A, if S0 is B, right? If S1 is B, print S0, S1, S dot substr 2. Otherwise, S1 is A. So if S2, yeah. Holy Christ, dude. Holy Christ. Holy Christ. Okay, that was horrible. Two different subsequences. We should have moved on. We should have moved on, man. What in the world? So I mean, it's either the whole array and something else or not, right? Yeah. Okay. C into N. X minus C into Y plus count Y. Alright, we should have not done that. We should have skipped A. Jesus Christ. Interesting sequence. Petya and his friend, robot Petya plus plus. Send end x, r is n. 1 is greater than x. While p is 0. While not in shift p and 1. Plus p. Why? Oh, okay, sure. So kill all lower bits, then add u. Send to end x, all r is n. We really should have skipped A. That was a terrible idea. Where is this home to an unusual species of spiders? Binary spiders. Okay. Alright, this part is stupid. My god. BLAN for LOXA C and X. True. Multi-test. Why? True. Why exactly? C to n, V all to n. Each thing up to x, rated n. Now add n plus 1, I 0 up to n. Add x dot pushback I, V all dist, par, vis 2. Max plus 1. Q, LOQ. C index to y, minus minus x, minus minus y. Well, not q dot empty. All x is q dot pop for y at VAX. Not vis 2y for LZ at y. This c is negative 1. For LY FVAX. If not vis 2y is 1. For LOZ at y, if this z is negative 1, this z is this x plus 1. Par z is x. Q dot push z. Sure. Don't need dist at all, but whatever. Petty and his friend, the robot Petty plus plus. Costume contest is taking place today. Runtime here? Why? 3e5 plus 7. VLF is factors I and get unique F. FVI is F. Vector VL at n plus 1. Oh, max plus 5. Yeah, that's dumb. Okay. Anything else? so odd positions in the subsequence northern and even positions in the subsequence southern. So merge the same things together. We don't want to touch zeros. So we'll ignore zeros. Bro, what is this? What is this? What is this contest? My God, dude. So I mean, once a minimum runs out, right? So we have some like set stuff going on. And so once this runs out, we subtract t from you, and we erase you. But what do we do? If we merge you at time t, then and for each of these we subtracted t from you. Yeah, okay. So we have to compress you. Why do you alternate between? Sure, okay. Now, set PL PQ. It's a 0. For I is 0, I also need that size, I plus plus. St dot insert. St dot insert I. PQ dot insert. No, you should be I. PQ dot insert AI I. If st.count px if it is not equal to st dot begin, ct plus equals CT plus equals PRS. What are you? So you're aimed PCT. PQ dot insert CTP. What exactly? Yeah. Abs AI. Why are you 5? Why? Come on, dude. So 0, 2, 1, -4, right? Two, 3. Oh, that's why. Okay. What was it knowing? C into n, VOA, all C is 0. I 0 up to n, C into x. If C is 0 or x is 0 or sine x is equal to sine C, C plus equals x. I'll say it, I'll push back C, C is x. C is not equal to 0. Abs AI, I, sine AI. Alliance is 0. While PQ dot size. Auto stuff is PQ up again. PQ dot erase PQ up again. X times equals S. St dot count px. Auto it is st dot find px. Well, ct is 0. Indus p cs is 0. st.count px, yeah. pr.s and r.s is equals x times sine ct. st.array it. Ct is not equal to 0. Cert pct. Yeah, okay. Sure, man, sure. Ugh. Bro, okay. Okay. Sure. 2, 4, -2, 2, -1. What's going on? ST is 0, 6, 1, -2, 3, 2. Ow. Okay, sure. Fine. Can you not? Sure. Laboratory on Pluto. Right. As you know, Martian scientists are actively engaged in space research. It's known that the lab we've built on n square blocks of equal size. It's a plane divided by vertical and horizontal lines into unit squares. Why? Why, man? Why would you make us solve u equals 1? What's the point of that? Genuinely, what is the point? Can I just leave? I think I'm just gonna leave. Screw this. God, man. A boring contest. With what, A? I don't know, man. I was just astounded by how not nice it was. Yeah, screw F. I'm done. I mean, it doesn't seem that hard. I don't want to do it. Let's go back to interesting stuff. You have no solves. And you have way too many solves. Okay. No. No, I will not. Alright, look at this one. Okay, so this one we can do. So I'm not gonna try this one, but what is up with this? Yeah. Yeah. What in the what? Yeah. Mm-hmm. 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 Cool. Cool, bro. Cool, bro. Ugh. Set versus farms, yeah. Yeah. Yeah, I mean, VODs are always available on this channel. So every intersection is also a constraint. That's the first thing. That's how we handle multiple constraints. Say that every intersection is a constraint. Every intersection is a constraint. So many, if we have two groups of size 3, right? What does that mean? Doesn't necessarily mean that every subset forms a connected set, but some subsets must. What does connectivity mean? So two things are not connected. So two things have some constraint that doesn't involve them. Doesn't necessarily mean they can't be connected. Just make sure we're reading this correctly. So we have to have the edge 3, 4. We have to have the edge 2, 3. Number of citizens, number of secret communities. Oh, so it can be 46. That's a problem. So what kind of constraint does this give? Think about this in a lot of ways. Think about this like paths, think about this like subtrees. What can we do? a lot of equivalent conditions. Say that we can't have any antinode between two nodes. So when is a subset of constraints inconsistent? If forces and edges, then obviously. What else? So if one constraint envelops another, then they're independent. They're completely independent. If one constraint intersects another, then they form a new constraint. If one constraint constraint what? So I can't have some node in the middle. Okay, so how would this work? How would this work? How would this work? Our network should be a tree. We're doing like the minimum number of edges. Okay. That's something. That's something, right? We're saying that the graph must be connected. And yeah, that's equivalent, right? If you're in between, you have at least two edges to you. So we're saying that every zero node must have at most one edge to the set of one nodes. That is not intuitively equivalent to the condition, but it's mathematically equivalent. Made a connected graph. So I'm going to settle on an equivalent condition that's useful, right? To find something useful. Something helpful. produce a connected graph then? There exists some bit set shenanigans that we could do. And I don't really want to do that, but yeah, it's something we could do in case we need it, but I'm not sure. Bit set shenanigans. So we build every edge we can, sure. So the idea is we need to build a connected graph. And then we can take any spanning tree of this graph. So for every pair of nodes such that you don't have a 0, 1, connect you together. Now we need to connect the graph. Yeah, sure. Yeah, we can do this. Okay, we don't need to bit set. we don't need to bit set. This is fine. No, yeah, we don't need to bit set this. So we combine the ones that are always the same. Sure. Then what? What do we do from there? We need to connect the graph. So now we know that every pair of elements has some difference. There's some constraint on each one. this. I mean, we can have some troll things, right? I mean, we might as well assume that every node is in its own group, because what's the point of doing that? Doesn't really help. We need to connect the graph then. Like, if every node is in its own group, right, then we have a bunch of restrictions, but none of them actually mean anything. Here's something like this. This can have almost so much of this, which is fine. How do we yes no? When do we get a contradiction? So if we have something like this, this has a constraint to this, and then this, yeah, so we're interested in like within constraints. So I mean, if we have a set, we have a set of constraints, so that your intersection is size 2. And these two must be connected. These two must have an edge between them. Is that true? Yeah, because iterated intersection of constraints is another constraint, right? We have two constraints that intersect at some point, some set. Yeah. Which is equivalent, but not helpful. Two constraints that intersect, forming another constraint. Can we thus for each pair, right? If you have a set of intersections that leads to you, this edge is mandatory. If you don't have a set of intersections that leads to you, this group is mandatory, but problem is like sets can be a size 1, which is weird. Sets can be of size 1, which is weird. And the edge between you is mandatory. Otherwise, it's not. Intersecting these constraints is complicated. Very complicated. How does this work? It's kind of hard to follow. So, okay, wait. So given the split into groups, if we're saying you must be internally connected, and it's saying you need to have exactly at most one edge between you. If a pair of groups are directly connected, look at the pairs of groups that are directly connected, right? Or what? No, it's still weird. It's still weird, man. Still weird. How is it so weird? So for any group, everything except the all zero group is special. Wait, what are we saying? No, we're not necessarily saying that, right? No, we're not. When two things intersect, we have to have this connected component in the middle, right? Because if you're not connected, then something's in between. And if something's in between, then it violates one of the conditions. If something from here is in between, which violates this. Or something from here is in between, which violates this. Wait, what? No, wait, that's not true. What am I saying? What am I saying? Yeah, these don't necessarily have to be connected, per se. Oh. Means this surrounds this, and then this hangs off this. lack thoughts. I lack thoughts on this. Feels like we just combine the conditions until we get something coherent, but hello. Feels like we just combine the conditions until we get something coherent, but I don't know. And I guess for the people who want to follow along, I update this like, well, once a day. What are you before? Yeah, sure. Alright. Yeah. Cool. I don't know why. Alright. I have no idea what that's about. I have a Discord in the description if you want to talk in private, I guess. But I'm not sure about that. Okay, so what are we doing here? how do we like measure this? Like we know that a subset has to be directly connected. If something. So we have sets of things that have no constraints with themselves. Now we have sets of things that do have constraints, and we're trying to add in some edges. I'm probably not into that. I'm kind of doing my own thing with my life. This is strange. This is very strange. It's very, very strange. Trivial DP, yeah. And to the end DP, I guess. actually not that bad to stress test for, but we need to, yeah, let's see. Consider any set of things. And consider that you're a minimal subset. To be a minimal subset. That means that there is no constraint that is as tight as this. Oh, okay. Bit sets. Wait. I mean, this would work, right? Wait up. No, yeah, this would work. This would work. um, okay. Sure, man, sure. Yeah, this would work. Yeah. Imagine solving problems, dude. Imagine freaking solving problems. Okay, yeah. Sure. So, bit set 2000 const 2005. Okay. Oh, this is stupid. All right. So how do we do this? How does this work? Okay. For I0 listen. Const I dot J S J minus 0. Okay. While one DSU D dot init n. Yes, it is. Yes, I use Ella for everything. Like literally, yes, it works. You don't have, you pretty much don't have to think about overflow. I didn't paste in my DSU. I don't actually need DSU, but whatever, makes life easier. While one bit set 2000 cur dot set for li0 I less than m is equal to cur and const I. If v dot count cur dot swap. Does this work? Fine. Cur is equal to v. Okay, sure. VL that if cur I back I that dot sizes and break for li0 I plus Can n be 1? Ugh. While n is greater than 1. Let's do this. If d dot merge at I plus 1, el dot push back at I at what? Do you compile? Oh, bool. Okay. Yes, okay. C or equals const ix y. Why? Oh, sure. What? Oh, wait, okay. El at j0, j less than n, j plus plus if const ij at dot push back j. If four. What is 4? DSUD d dot init n. For auto x y el. If const ix and const iy d dot merge x y. Marks d dot marks Oh, because we're modifying it. Vector string vs. Damn. Vs ij is equal to 1. Ay. Wait, why? Why does this not work? No, because we're merging it arbitrarily. Okay, we need to like be smart about this, right? So we can't just merge you with the rep. Does this work? Wait. So we have that in every constraint at least one of you is set. Yeah, okay. This is fine. We can do this. Last equal to -1. Curs v last equal to I. cur I, good I is 1. Now, if vs last I is equal to 1, I is 0, I plus 1 is less than at dot size, I plus plus. If d dot merge at I plus 1, el dot pushback at I plus 1, done is 0. If vs last I is 1, and cur d dot marks I, y. What? Where? Where are you seg faulting? PR at. Why? There we go. And 1, 2 is fine. Yeah. All right. I don't know. I don't have the most faith in this, but we'll see. Scene to m, vector string vs m. For I 0 up to m, scene to s vs I is s. Cons I j is equal to, I don't know why we did that. Sj minus 0 dsud, vector plel. Current cons I. Cur is v, last is I. If last is negative, 1 break. VL2. Cur I 2 dot pushback I. VL at. So we have you, and we must merge you together. Yeah. Both done is 1. Done break. R is d dot marks 2 0. D dot merge x y. R is d dot marks at dot back, pause and equals d dot marks x as r. Sure. Sure, man, sure. Sure, dude. Nice. All right. I guess it's time to do stuff. So I mean, we're not constructing any tree that we okay. N is equal to 10. S equal. What in the world? No. Okay. Yes. Okay, so immediately you're broken. Oh wait, S2 dot erase K. This K is 1. Okay. Is 4, 5. Is 1, 2. Nice. Alright, we can pass 3. We cannot pass 3. Why are we not passing 3? Oh. Okay, yeah, this is the problem. Okay, yeah, this isn't working. Fine. How do we fix this? And t is greater than or equal to 2, and t less than LC. Oh yeah, okay. Alright, this is stupid. Stop doing this. Okay, we're allowed to do... We need to better, how does this work? there's no set within you that needs to be smaller. And that's fine. So we know that there's no set within you that needs to be smaller, which means this is fine. But then we have these sets that we have. How does this work? Okay, here we go. So let's stop this and do something else. So if cur I, so getting rid of 2. Wait, how does this work? So we had this previous set that we identified. Now, if everything contains this, then we're done. Wait, if every set contains this, then what? What does that mean for us? Wait, what does that mean for us? If every set contains this, then we need to merge these two together. Now these are one component. Now we need to, do this. Okay, so we do kind of need this. But then the issue is actually producing the tree. So this will give us a yes, no. No, it won't. It won't even do that. We need to produce the tree. How do we do this? if there's some representative that works, if there's some representative of this, what are we looking for exactly? Like, what are we looking for? Let's go with correctness and then do this bit set stuff, right? What exactly are we looking for? So we know that now, because these have been merged, because we have a set that intersects to this, that these must be merged together. We have a set that intersects to this. Now that these must be merged together, we do that. We merge them together, and then what? And then we know that then sure, we can tell that these must be merged together. And the question remains how? How do we do this merge so that we satisfy all constraints? How do we do this merge so that we satisfy all constraints? Or fail to, if impossible. So I mean, the hard case is really tight possible, right? How do we wait, we can like DSU shenanigan this, right? Can't we? So like if you strictly contain this set, if you have this as a requirement, then we do this. If there is some cell that must be merged with everything simultaneously, then we're screwed, right? Okay, I have an idea. Let's set a rig so I don't need last. CV is equal to CV and a rig I. Okay, So if CV I. Okay. Cool. Right. Come on. Okay. Nice. Okay. All right. This works. This is correct. Now we need to see if you're fast enough, right? So n is 2000. 0, 1. Okay. Oh God, dude. All right, so okay, 64. Let's do that blog, right? There is this blog that has stuff. Okay, let's do this, right? So we do this stuff. Yes. Do you work? You're about the same. Where do I need to put you? I need to put you like up here. Oh, and then we do bits here. Am I getting a text? No. Nice. Okay. Let's see it, dude. Let's see it. Let's frickin' see it. Come on. Come on. Damn, they actually delayed my college. Huh. Did they really? Because of the snow? Wait up. Damn, they actually delayed college because of the snow. That's wild. This is gonna work, right? It's gonna work, right? This is actually a really smart way of generating test cases. Like this makes some really strong cases. It's gonna work, right? It's gonna work, right? 200th person to get this problem. Nice. It's gonna work, right? Damn. Wait, it was faster than my tests. 33? Holy. Okay. Wait, that makes no sense. How are you 33? How is this 33? How did they decide this was 33? Okay, whatever. I mean, I'll take it. Like, sure, but what? Okay. How, like, how, I'm betting this is this, wait up. Is this intended? This is intended? Are you serious? No, it can't be intended. It can't be freaking intended. Inset. Not inset. Nice. What is kill set? Okay. Maybe. Yeah, this kind of seems bit setty, but I guess it's faster. That's crazy. Is that actually that's actually You told me that's intended. You told me that's intended. Damn, man. That's wild. That's wild. That's wild. That's actually wild. Who would have guessed you would need bit set for this problem? Who would have guessed? That's crazy. And this is just like a I don't know. Yeah, this is interesting. This is an interesting idea. Cause like, yeah, you have to like VL2 cur I 2 dot pushback I VL at CVI at that pushback I. We don't need 2, but no, we do. Yeah, we do. Yeah. Okay. So there has to be a representative. Like there has to be a representative. If there is not a representative, then we have two things that need an edge between each other, which is just not possible. So that can't be true. So if we have a representative for each component, then either merging that works or it doesn't. If we have some representative, right? Then either merging that works or it would have never worked. So that's fine, yeah. Damn, man. Why were my cause this takes a while. Cause my test generation takes a while. Okay, I see. Okay. So that actually matters using ordered set. That's fine. Yeah, actually that makes sense because that's like n squared log with a really bad log. Sure. Okay. Cool. Frickin' bit sets. They need a bit set tag. They need like bit masks here. Something like that. Actually, if it's not bit set, I mean, I don't know. Like this doesn't have the bit mask tag, but somehow like, I mean, you could probably do it without. There's probably a way to do it without. Like you can probably do it without. I don't know. How is this 33, by the way? That rating doesn't make sense. Doesn't make any sense. Why would it be 33? Why would it be 33? Oh, the epic convolution. Damn, yeah, 200 sols. Nice. Bit set, eh? Just pick a random submission. Does it use bit sets? Does it? Wait, does it not? Oh, it does. Okay. PI and PJ dot count IJ. Okay, whatever. It's another solution. Sure. So why did they set a 2-second limit then? That's kind of mean. How many people got TLE on that because they had suboptimal? I mean, I have. So it's 2 times n times m times n over 64. And we have the bit set speed up, which is useful. I guess without that speed up, it'd be worse, right? Because we're doing twice the amount of bit set ops per thing because I have to do this weird, I have to do original and new. No, whatever. Cool. This is such a strange, this is such a strange approach. Just take a set and then just subtract from it while you can until you can't anymore. And then because you can't anymore, that means that this is minimal. So you can force merge them together. And then you merge them together. You assume they're in the same components, and then you repeat. That's strange. It's a strange solution. That's really strange. How many no cases do they have? That's a lot of no cases. Nice. Yeah, a good way to generate tests is have a valid tree and then add constraints based off it. Interesting. So what took a while then? Hello. Linear pruning for bitset? What's that? I don't know what that is. What do you mean linear pruning? Is that something that would actually make it faster? All I did was do a thing. All I did was oh, I could have used Pragma pop count. No, they already have that, don't they? No, they don't. Yeah, you could use Pragma pop count for this, I guess. That'd make it faster. Let me test that. I kind of want to see. Let me try with Pragmas. Kind of curious. I've never heard of this thing you mentioned. Oh, that's much faster. Okay, nice. Okay, that's 3 bitset ops, one of which is a count. And I guess the other pragmas make life easier too, because bitset's just like literally a loop, so it can totally be parallel vectorized. I did last contests at the beginning of this stream. You can rewind or check the VOD once it's over. It should let you rewind to the very beginning. I think YouTube is fine with that. I did the contest and then briefly went over solutions, I guess. Okay, what to do now? It's kind of too late to start another problem. So what? I think I'm gonna take Wednesday off just for the sake of not being tired for the contests I have to do. So that leaves one more day, pretty much. I really need to fix my DSU. My God, dude. Like seriously, I really need to. Let me make a copy of this. Okay, now we can get rid of this. This is so dumb. Why do I have this? Okay. What problem? Like the one I just did? This graph problem? I am not entirely sure how that's the same. What do I do? I don't really want to start another problem, but let's see what's over here. Oh boy. So D and E are kind of mutually exclusive. But they're both like not that high rated, are they? And F's kind of insane, I guess. Lasers and mirrors. Dude, that sounds like a nightmare. I'll look at it tomorrow. And D, D's not worth it, right? Yeah, D has too many cells. It's like 2,800 something. Damn. Okay, what do I do? Did we skip this? No, this was this one. Yes, this one. Nobody finished this. Nice. How do you... Okay. Yeah, this one I did before. And this one is a geometry 3500, right? It's 35, right? Yeah. A geometry 3500. Imagine that. We did virtual this a while ago. Not on stream, but yeah. Freaking 3500. Code Chef. Sure. I like open pruning for bit set. Like bit set or like hash map? Those seem mutually exclusive. There's a lot of div 2s. A lot of div 1s actually. Like a lot of div 1s in a row. Let's solve some div 2f. How hard is this? Sure. They're in cities. People travel between cities by some one-way roads. You can't start a trip in it. Kingdom can be viewed as an acyclic graph. Oh, it's this problem. Oh, it's this problem. Semi-important if it is not important, and we can destroy exactly one city so that U becomes important. We can destroy exactly one city. I've seen this and I don't want to do it. Yeah, let's not. They're 9 cities in the country. 2 candidates are fighting for the post of the president. Both plans will connect all cities using M-1 roads only. That is, each plan can be viewed as a tree. Both of the candidates had also specified their choice of the capital. I've seen this one too. Why have I seen this one too? Why have I seen this? City number and the number of ports in its subtree. Why have I seen this? This is a flow problem. Why have I seen this? Why have I seen this? Why do I remember this problem? What in the world? I know this is a flow problem. I remember this. I don't know why I've seen this. City number and the number of ports in its subtree. Exactly exports. Is it? No, it's... Find out the maximum revenue that can be gained while fulfilling all demands of both candidates. I remember this, man. I remember this. So we what do? We direct the tree and then, oh, it's flow with demands. Wait. No, it's not. It's not. No, it's not. Is it? Wait. Is it? And we need there to be a certain amount of flow to pass through this edge. I think Gabe solved this and he derived flow with demands on the spot somehow. Somehow that's it ended up being equivalent to that. Min cost flow with demands. My god. Okay. Well, that's cool. That's cool, man. And we can mandate that a certain amount of flow pass through each edge, yeah. No, wait, hang on. That doesn't exactly work. Because it has to happen in both trees. Yeah, no, that doesn't exactly work. Never mind. It's not that simple. God, I remember this. I remember this problem. City number and the number of ports in its subtree. Why do I remember this problem? But it's weird. But it's weird. I don't know, whatever. I don't want to solve a problem I've heard of already. Ah, wait. Wait, what? Somehow I've like seen every round. Look at this one. Why are div2f so weird? Test in a programming class. Even n-ordered segment sets. Each set P contains at least one segment LR. Oh my god. Oh my god, dude. Contains at least one segment LR that lies entirely on the segment XY. Of course, with div2 is to force online, right? Of course. Number of sets, queries, and segments. Pair of two integers LR, where L is less than or equal to R. They want us to do persistence. They really want us to do that? Are you serious? I mean, we could do it with persistence. Like, we can do it with persistence, right? Because, like, you sweep L, and, are you serious, bro? You sweep L, and then an answer to a query AB is the maximum right endpoint of it. So like we sweep L for each set, we keep track of the minimum right endpoint such that your left endpoint is at least L. And then, yeah, persistence. Well, no, I'm not doing that. I'm not doing persistence. And if they don't want persistence, then that's dumb, because that's bro, bro, like, bro. My God. What is it with div 2s? The flow problem looks kind of interesting, but I don't really want to do it. Don't really want to do it. Right? Like what's with that problem? Where are we going from? What time is it? Oh, wait. Yeah. How in the world does this work? Okay. Yeah. We looked at this one already, right? Yeah. Just mind solving some div 2 stuff. I guess. Why not? Why have we like solved everything from... What is with div 2s? What is with these? What is this weird distribution? I mean, div 2s used to be a lot worse. I will say that. Like, they are better now, but still, man, like, some of them are so painful. Like that one. Are you serious? Okay. Like that one I virtualed today, like, that was awful. Like, my God, that was horrible. That round. I don't usually like leave rounds mid contest, but that one I could not with F. Straight up could not. Are these easy? Yeah. I want something hard but like not hard, you know? Like I want something hard but like something I can solve, you know? You know what I mean? We've looked at this one. Why have we looked at this one? It's too easy. Oh, we virtualed this one. Or we quote unquote virtualed this one. I remember this. Yeah. Okay, fine. Their end dish is sold in the city. Each dish I has a price PI, a standard SI, and a beauty, a BI. Each person, oh my God, that's a lot of parameters. That's a lot of parameters, dude. Jesus. Person would never buy a dish whose standard is less than the person's income. Also, a person can't afford a dish. Okay. If BI price of the dish is less than the person's income by K, the person will only allow the absolute difference of at most K between the beauty of the dish and her preferred beauty. Like, oh God, dude. What in the world? What in the world? Okay, I mean, we have to break the absolutes somehow. What in the world? What? Person would never buy a dish whose standard is less than the person's income. Also, a person can't afford a dish the price greater than the income of the person. Yes, sure. We could do this with a 2D something, right? If pj is less than or equal to inc j is less than or equal to si. This is kind of tricky, isn't it? When did I start? 2018, something. It's a long time ago. End of 2018, I think. I started CF in like what, May 2019? Yeah, June 2019, either way. So yeah, it was like late 2018, like December or something. Coincides with the USCO contest. Okay, so I mean, if we break the absolute, then it's inc j plus pref j is greater than or equal to pi plus bi. So if we fix that bi is less than or equal to this preferred, God, dude. What? What? There's so many constraints. My God. This can't be nice. Like, this is not a nice way to handle this. Dude. Christ. Why are we doing this? Why are we doing this? Why are we doing this problem? Why are we doing this problem? Why are we subjecting ourselves to this? What is this? What are we doing here? Okay, we need to break the absolute, but how do we break the absolute, right? So I mean, so, bro. Hang on, wait. Bi minus pref j. We can break the absolute, right? Yeah, we actually can, right? Bi minus pref j. If we just have this absolute condition, then like that's just negative x. Like if abs x is less than or equal to y, then that means negative y is less than or equal to x is less than or equal to y. Which is fine, I guess. But if we do that, then we can't. God, dude. Okay, so I mean, we can handle the income part with interval stuff. We can do the range thing like that. Then we need to insert bi plus pj into a set or something, right? So we insert all these, we insert or delete all these. So we kill one dimension. And then the other dimension is over all things where bi, where pref is less, preference of I is less than or equal to bi. We count the number of guys where bi plus pi is less than or equal to inc j plus pref j. We can do that with the merge sort tree thing. What is fractional cascading? This is actually like, sure, okay. Okay, so, no, but it has to be dynamic. It has to be dynamic. Oh my God, it has to be dynamic. Okay, but we can, my God, dude. We can do it with a Femic tree. Okay. So we can do this with 2 logs, I guess. I guess we could do this with 2 logs. Okay. This problem is absurd. This is absurd. What difficulty are you? 25. Jesus. A divide and conquer. Does that work? Why would that work? Why would that work? Fix a person. What? Why would that work? Why would that work? Why would that work? Why would that work? Okay, whatever. 25. Bro, this is such a heavy problem. Like, this is so heavy. There's just so much to do in this problem. I mean, it would work. It'd be log squared, right? Like, it'd be fine. It'd be fine. It'd be fine. It would be fine. Like, it would be fine. It would be fine, right? Yeah. All the submissions to this are heavy. It would be fine. It would be fine. Like, it'd be log Fenwick. It'd be nlog Fenwick queries. Nlog binary searches and nlog Fenwick queries, which is like fine. I just, bro. Okay. I don't want to mark this as mind solve. This is stupid. This is not worth marking. Okay. We're not getting burnt out. Kind of am, honestly. Not exactly burnt out, just like tired, I guess. Which is not exactly the same, because burnt out is kind of a mental thing. Not exactly like mentally out of it, I'm just like physically tired. Which, makes sense, but whatever. Also, being hopeless on a problem is kind of hard, but now that we're just doing random div2 stuff, it's like easy. We're not really. This isn't really practice. I'm just finishing off the day, counting down the last few minutes. Are you interesting? I don't want to do this. Okay. Cool. All right. I'm probably gonna call it here. So tomorrow is last stream for a while, cause I have a lot of stuff in the second half of the week. Easy is relative. It depends on the div2f. I mean, some div2fs are impossible. Some are not. I mean, not necessarily like easy. They're just like easier than the stuff I'm like easier than 3000s, which is my normal stuff I chew on. Yeah. All right. I'm gonna go. If people want to talk, it's always the Discord. Always. Nobody does, but it's fine. Okay. Goodbye.